Hello. So this stream here is a continuation of one I did before that I did cut in the middle about largest smaller BST key, and so I stopped at this here. So basically, what we did so far is doing an in-order traversal to get a sorted sequence, and then we stop as soon as we found an element that is bigger than what the element we are looking for, the largest smaller element than it. And then when we found that, we just returned the previous element, because for example for 17 we stop when we reach 20, which is bigger, the first element that is bigger than 17, and we return the previous element, which is 14. And we are doing the bigger than or equal because if the element we are looking for is 25, then as soon as we reach 25, we need to return the element before it. If we did do only bigger than and not bigger than or equal, we would go, let's say if there was another element here, 34, we would go until 34 because it's the element that is bigger, and we'll return 25, which is not the answer, because what we want is the largest smaller number. So what we need to do is do bigger or equal. Yeah. And so we did our processing step of in-order traversal, and now we need to initialize our previous value. And so the previous value, if it doesn't get updated, that means, let's say for a sequence that is like let's say 16, and we are looking for 20. Maybe that's not the answer. Actually, yeah. Let's say we have 10, and the answer is 20. So if we are looking for the largest smaller than 20, and we have just 10, then we won't find this condition at all. So in that case, we need to return -1 because there is no such a number. So we need to initialize this to -1 and return previous. And yeah, so that's about it. And yeah, so I have some test cases here already set. So let me just show you on the tree for each. So in this tree, if we are looking for 17, we should return 14, because the largest smaller than 17 is 14 here. If we are looking for 26, so the largest smaller than 26 is 25. If we are looking for 25, the largest smaller, not smaller or equal, smaller is 20. So it should be 20. This is basically the edge case on the right, and we need an edge case on the left. Let's say a value 4, for example, which is less than 5, and there is no element smaller than it in the tree, and so we need to return -1 there. Yeah, so that's what we are doing here. Now let's run this and see if it passes all the test cases. Okay, let's run it again. Okay, so now it passes all test cases, and the basic idea is to think about which traversal would help us to solve the problem, and then depending on whether it's in order or pre-order or post-order traversal, we will still do a processing step that changes, but the iteration or the traversal is still the same. The traversal template is still the same. And yeah, that's all about today's problem. See you next time. Bye.